On example 5, we're going to be showing an application problem that involves proportions. Anytime you have a fraction equals a fraction, that idea taken together is called a proportion. So in any proportion, we're going to clear fractions. And you can also consider when we clear fractions, kind of the shortcut on that is when we multiply A times D, that's going to be the same thing as B times C. That's what we say in math, that in any proportion, the product of the extremes is equal to the product of the means. Basically, it means you can cross-multiply when you have a proportion. That's a shortcut to clearing out those fractions. Here's an application problem involving proportions. On example 5, it says to estimate the number of bass in a lake, a biologist catches and tags 24 bass. Several weeks later, the biologist catches a new sample of 40 bass and finds that 4 are tagged. How many bass are in the lake? So basically what we're going to do is we're going to talk about the proportion of the caught and tagged to the total. That is how we're going to set up the fractions within the proportion, the ratios within the proportion. So on the first go around, the biologist caught and tagged 24 bass. So he tagged 24 out of the total number of bass in the entire lake. That's what we don't know. That's what we're going to let X be. That is proportional to what happens several weeks later when he catches a sample of 40 bass total and finds that 4 are tagged. Now, when we set that ratio up, we still have to follow the same guidelines here, where 4 are tagged out of the sample total of 40. So we have tagged is to total as tagged is to total. We can solve this proportion by clearing fractions. And like I was telling you, in a proportion, the shortcut is to cross multiply. So 24 times 40 equals 4 times X. 24 times 40 is 960. Divide both sides by 4. And so X, which we didn't write that, we probably should have said what is X. It's the total bass in the lake. And that is what we're going to get when we solve for X here. X is equal to 960 divided by 4. That comes out to be 240. And we'll label that as total bass in the lake. Now we're going to wrap up this chapter by filling in the blanks for the concept connections. Number 1 says if $6,000 is borrowed at 7.5% simple interest for 2 years, then the amount of interest is, remember our formula, interest is equal to principal times rate times time. So the amount of interest is going to be $6,000 times the interest rate in decimal form, 0.075, that's 7.5%. The time is in years, so times the time of 2. Now, multiply on your calculator 6,000 times 0.075 times 2, and that comes out to be 900, and the label on that would be dollars, $900. Simple interest. On number 2, it says, suppose that 8% of a solution is fertilizer by volume and the remaining 92% is water. So how much fertilizer is in a 2-liter bucket of solution? To calculate that, like when we set up those mixture problems, I said now it's a matter of taking percent times amount. If we want to know how many liters of fertilizer we have in that 2-liter bucket, we take the percent of fertilizer multiplied by the 2 liters, and that will give us 0.16 liters of fertilizer. This says if distance is equal to rate times time, then solving for time, we would divide both sides by r. I think it's a little bit too difficult to fill that in there. Time is going to be equal to the distance divided by the rate. If distance, number 4, if distance equals rate times time, then solving for r. To solve for r, we would divide both sides by t. R would be equal to distance divided by time. Solving those literal equations for time and then distance in numbers 3 and 4. And number 5, the formula for the perimeter of a rectangle with length L and width W. This might be one of those formulas you need to know from geometry to get those types of problems set up. Let's draw a little rectangle that has a length of L and a width of W. Okay, that also means that up here that's an L amount and over here that's the same width. And so perimeter is length plus width plus length plus width, the distance around the figure. Now when you combine the fact that we have 2 of those lengths in our problem, and as well as 2 of the widths, the most concise formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. In number 6, the sum of the measures of the angles inscribed inside of a triangle. Remember that the sum of all the interior angles of a triangle will add up to be 180 degrees.